We're here today at the Lincoln soil pit, and we're going to take the opportunity to demonstrate to you the process of doing an analysis of soil texture, something that you can do for yourself. So we've got lots of layers in the soil. We've got our nice rich dark topsoil in this instance, and this clump of soil effectively is demonstrating the plant growing in the top layer, and the roots penetrate further down. So we've dug this clump out to represent the first layer. And what we're going to do is take a sample of the top horizon, the A horizon, and then a sample of the B horizon, and we're going to do a jar test. So we've got our tarpaulin, or an old fertiliser sack, and we're going to lay the layers out in order that we dig it out of our hole. So we've got our grass sample from the turf, and this is the spade full of material from that top horizon. And we put that onto the ground first beside our grass sample. So now we've dug further down into our hole, into the second horizon, or the B horizon. And you can see a dramatically different colour and texture, and we lay that out next on our tarpaulin. Now we want to create our samples to test in our texture test, a jar test. So we're going to take our soil, and we want to get rid of the organic matter. We want to get rid of the roots. If there's any worms, set them aside, so that we just end up with just the sediment, just the sand, silt and clay left over. So we carefully take some time to remove that, the remains of the roots and that other organic matter. So we're going to do the same with our B horizon, and you can see it's a lot easier. There's not a lot of root material in this sample to be able to get a nice clean sample of the sediments. Our next step is to put our clean sample into a glass jar. So we take our 100 mils of soil and put it into the jar. Make sure you've got any last bits of organic matter out that you might find in that process. The last thing we want to add is about 200 mils of water, or about twice the amount of water than the quantity of soil. We close the jar up and seal it tight. Hopefully the lid doesn't leak, and we give it a jolly good shake. And we want to shake it for quite some time until all the particles have broken up. That could take a couple of minutes. After we've shaken the sample up, we find somewhere to sit it that's going to stay for a long time to allow it to settle out. And you can see this sample's been sitting a while, and already the layers are starting to settle out quite distinctly. The sand is at the bottom. It's the heaviest particle, so it settles out almost straight away within a few minutes. The silt is a bit finer, takes a while longer for it to settle out, and it's forming a darker layer just on the surface of the sample. And the clay can be so fine, it may take it could take 2 or 3 days to settle out, and sometimes with some clays it'll never settle out, it'll just continually stay in suspension. So what we want to do, once it's had its time to settle, is measure those layers. What we can see is the total depth is about 32 millimetres from the bottom of the sand to the top of the clay layer sitting right at the top. And we take a note of each thickness of each layer. So we've got about 26 millimetres of sand. We've got about 4 millimetres of silt, and then just a trace of clay sitting up on top. We're going to write down those depths of each of the layers, and we're going to do some calculations with those. Next, we're going to do exactly the same process with the next horizon, our B horizon. This sample from our B horizon is clearly different to the A horizon. Still around about the same depth because we put the same quantity of sample in, but the sand is almost the entire profile of this particular soil. The name of this soil is a Templeton sandy loam. So presence of sand is something that we would expect to see in this sample. The silt and clay layers are almost undetectable. So this is just about pure sand. So thinking about our macropores and the drainage of water through the profile, this subsoil has very low water retention and will drain very, very easily. Once we've gathered all those depths and we've written down the millimetres of each layer, we're going to take that information and put it onto our soil texture triangle, and that will tell us the texture and the name of this particular soil. From that texture name, we'll be able to look up on a chart, and that'll tell us some of the characteristics of its water holding capacity.